Okay, so what we're going to do here is we're going to take the base function y equals log x base 2 and transform it into the function negative log of 2x plus 6 with a base of 2. Okay? And one clarification I want to make here, or one modification I want to make, is I'm going to change that transformed function to this. Why?
Because you have to factor it out anyways.
Yeah, you have to factor it out to know what the actual horizontal translation is, right? This is 3 to the left, not 6 to the left. Okay? So I'm actually going to do this. I'm going to go from here to here. Okay. So order of transformations, what's the first one I'm going to do?
Stretches and reflections.
Stretches and reflections. So let's do this one first. What does this negative do? Reflects in the x, right? So that just flips all the y values. So that'll be our first transformation. So we'll have y equals negative log x base 2. The next transformation we're going to do? The horizontal stretch. What does that do? It's a horizontal stretch by a factor of 1/2. Well, what does that do to the coordinates?
Halves the x value.
Halves the x values. Good. So we'll do this one next. And then the last one, I'll make it green. We're going to translate 3 to the left. Okay, so I'll just write this last one in green so that we can compare the colors. So this is negative log 2 times x plus 3. Okay, and I've chosen some points. A way of getting these points could be if you just graph this function, that function there in your calculator, and then went to the table of values. Just pick some whole number values so that they're a little easier to transform. Okay, so just to let you know, I'm not picking them out of thin air. They're just easy points to work with. Okay, so the first transformation we're going to flip in the x-axis. So what happens to 1, 0? Nothing, right? If I make 0 negative, it's still 0, so that doesn't move. What about 2, 1?
2 negative.
Good. 2 negative 1. 4, 2? Good, right? Just all the y coordinates become negative. Or they change signs. Good, that was simple. Okay. The next transformation, what does this 2 do? Halves all the x values, right? So I have the ones that I had previously, okay, from the last transformation. So this is 1/2 0, and then 1 negative 1, and then thank you, 2 negative 2, and 4 negative 3. Okay, and then the last transformation occurs or affects these last transformed points. We just move them all 3 to the left, which means we minus 3 from the x values. So this becomes negative 1/2 minus 3. What is that?
Is it negative 1/2? Or is it just 1/2?
Sorry, it should be 1/2 minus 3. It should be negative 2 halves, right? Or negative 5 over 2. Okay. So negative 5 over 2, and still 0. 1 minus 3 is negative 2, negative 1. 2 minus 3 is negative 1, negative 2. 4 minus 3 is 1, negative 3. Okay? So I'm going to plot the original function in black and the transformed function in green. Okay, and do the same on your papers there. Okay, so let's get a bigger dot. 1, 0, 2, 1, 1, 0, 2, 1, 4, 2, 8, 3, 4, 2, 8, 3. So here's my logarithmic curve. It's got an asymptote on the y-axis. Okay, and then the green function, -5 and 0. Sorry, -2.5 and 0. That's there. -2, 1. Sorry, -2, -1. Am I going too fast? -1, -2. And 1, -3. There we go. Okay. Yeah, it got flipped on the x-axis, remember that. So it'll be upside down, right? So I've got something that so far looks like this. What happens over here? I mean, it doesn't just stop there. Does it go like this? Is it a little steeper than that?
The asymptote would be a negative 3, right?
Yeah, where would the asymptote be? That's the question here. What affects... What was it? Oh, what's the original asymptote? Maybe ask that.
Zero.
X equals 0. And what would have affected that movement of that asymptote? Which transformations would have affected that? The horizontal translation. Would this affect it as well? It would if it was something other than 0. Right? But because it's x equals 0, you half 0 and it doesn't move, right? So the only thing that's really being affected but the only thing that's affecting it is the horizontal translation. So there should be an asymptote. Maybe I'll just draw that in red. There should be an asymptote here. Oh man, that's a nice line. Okay. So my green graph is going to be approaching that line into infinity. Okay. So there we go. This green graph is -log 2x plus 6, and the black graph is my original function. Look familiar? Should be, right? Any questions on that? Need it there for another second? You okay? Okay. So let's identify some of these characteristics. Okay, for B. What is the equation of the new asymptote? X equals -3. Okay. Domain and range. What's the domain?
X is greater than -3.
Good. Not equal to, right? Because if it was, then it wouldn't be an asymptote. You guys remember the first time you learned this? Domain and range. Grade 10s learned it on Monday when I wasn't there.
Oh.
Hopefully that went well. Range?
Everything greater than...
Real numbers.
It's everything, right? Even though this looks like it's kind of flattening, if you were to go out to infinity, this would just continue to drop. Even though it kind of looks like it's getting less and less, which technically it is. It's getting flatter and flatter and flatter, but always deeper into the y values. Kind of a strange thing to think about. Something that can continuously get flat, forever get flat, but never flatten out. So we have all real numbers there. Good. Y-intercept. It looks like -2.5. How can we check for sure? Yeah, we can use the equation. How? What do I need to do to the equation to find the y-intercept?
0. Put 0 in for x.
Put 0 in for x, right? It's where x equals 0. That's where it crosses the y-axis. So let's just do that really quick. Y equals -log base 2 times 0 plus 6. So really quickly here, This is log 6, or negative log 6 base 2. So, what will that equal?
-2.5.
Negative 2.5. So we drew our graph pretty good. Nice. So there's our y-intercept. 0, negative 2.5, stated as a point. And then the x-intercept, it does have one. That one we plotted as a point. Should be negative 2.50, right? So the x-intercept is negative 2.5 and 0.